All right, welcome back. And today we are going to finish our chapter review here. And I'll go over a little bit of what you were supposed to do for homework today. It'll be due tonight. So you'll be able to get some help with that if you need it. All right, let's pick up with number 43 here. So if I'm trying to find my domain, then what I need to do is I need to find a number that I would plug in, which would make this not true. I can't take the square root of any negative number and come up with a real solution, so that would be a problem. So what I actually have to do is I have to solve this so that 16 minus x squared is greater than or equal to 0, because I can't ever have it where it's less than 0, right? So the first thing I'm going to do is subtract 16 over. It gives me negative x squared is greater than or equal to negative 16. Now I divide by a negative. Don't forget, when you divide by a negative, it flips the inequality. So I have x squared is less than or equal to 16. Then take the square root, and that gives me x is less than or equal to 4. Don't forget, when you take the square root of a variable and the square root of this side, it gives me a positive and a negative value. So x has to be between negative 4 and 4. If I go above 4, if I was to say to plug 5 in here, 5 squared is 25. 16 minus 25, everyone knows that's negative 9. Square root of a negative is not going to work for us. So it has to be between negative 4 and 4. So that's my domain value. If I wanted to put it in some terms here, the interval notation, I could do bracket negative 4 comma 4 and another bracket because I have the equal sign underneath. When I look at my range is going to be what's going to be if I do 16 minus 0. That will give me the square root of 16, which is 4. And think about when I put the highest number in possible, which would be 4. 4 squared is 16. 16 minus 16 is 0. So I'm going to be going from 0 to 4 for my range. Okay. Looking at number 44, there's no real restrictions on my domain because I just have an exponent value. Not a big deal if that was to be a negative exponent or a positive exponent. It wouldn't change it, so this would be all real numbers as well. We weren't worried too much about the tangent and the sine ones, and definitely not the natural log one. Really just kind of focusing in whenever we're looking at the square roots and then a denominator where we have a variable in the denominator. All right, let's move on to the piecewise functions. It says find the domain and the range for this. So the first one is the square root of negative x when x is between negative 4 and 0. So basically, if I plug a negative 4 in, a negative of a negative gives me a positive 4. So I can take the square root of that. And that's for any time where x is less than 0. So since x is less than 0, it's always going to be taking the square root of a negative negative, which is always the square root of a positive. So that's going to work for all of those. And additionally here, if I'm going from 0 to 4, I can always take the square root of these positive numbers. So our domain in this case, I said domain and wrote range. Our domain in this case is going to be negative 4 is less than or equal to x, which is less than or equal to 4. Now let's figure out what our range would be. If I put a negative 4 in here, that'll give me the square root of 4, which is 2. If I put a positive 4 in here, square root of 4 is 2. So my highest number appears to be 2. If I look at putting 0 in, square root of 0 is 0. So now I'm looking at a range that is between 0 and 2. won't ever go higher than 2. Won't ever go lower than 0. All right, let's look at 52. For this one, I have negative x minus 2, and my domain is going to be every possible value of x. So basically, it's going from the lowest one to the highest one. And I have a lot of less than or equal to signs in here. So if it's less than or equal to negative 2, that tells me that I have a bracket first. I literally did the same thing here. Then negative 2. Then this is just a greater than symbol, but it's less than or equal to, and less than or equal to on this end. So my domain goes from negative 2 to 2. If I look at my range, look at the lowest value, negative 2, negative of a negative 2 gives me positive 2. Positive 2 minus 2 is 0. Think about plugging a negative 1 in. I have negative 1. Negative of a negative 1 minus 2, so that's negative 1. So we're looking at really 0 and negative 1. For this one, if I plug in x, it's going to be negative 1 to 1. So my lowest value would be negative 1. Highest possible value would be 1. And here, if I plug in a 2, that's negative 2 plus 2, which gives me 0. Plug in a 1, goes from negative 1 plus 2, which is a positive 1. So my lowest value I can come up with is a negative 1. And the highest value I can come up with is 1. So that's my range. In exercises 53 and 54, write a piecewise formula for the function. So if I look at this, say we'll do 54. So if I look at this, then when x is between 0 and 2, it's following this function. So let's find out what that function is. It's a straight line going up, so that tells us it's linear. My slope is up 5 over 2, so that would be 5 halves. So it's 5 over 2x. Positive slope, so it remains a positive. And that's between the numbers 0 and 2. When we look at the numbers between this one and this one, going from 2 to 4, when I look at those ones, this is now a negative slope. It goes over 2 and down 5. So it's going to be negative 5 halves x when x is between 2 and 4. Stops at 4. It's a closed dot here, and a closed dot here. So I know I have greater than or less than or equal to here. This one I just put less than, but it could also be a less than or equal to, and definitely less than or equal to 4 because of the closed circle. Might as well go back to 53 and look at that one. If I'm looking at this, then my x here, this line, it's got a slope of negative 1, so that's going to be negative x, and that's when x is between 0 and 1. You'll notice the open circle, that tells me that I'm going to leave it just less than 1. And by the way, this started at 1 minus x. Since it started at 1, it's got to be 1 minus x, sorry. Let's look at the next one. So this one also starts at 1, and then it's dropping down from 1 to 2. So this one is also going to be 1 minus x when x is less than or equal to, or greater than or equal to 1 and less than or equal to 2. That's definitely not right. The 1 minus x. It's going to be 2 minus x. Sorry. So if I look at this point here, when x is 2, y is 0. So 2 minus 2 is 0. If I come back to this point here, when x is 1, 2 minus 1 is 1. So that gives me 2 minus x as my equation. And so those are formulas for those two piecewise functions. All right, looking at composite of functions, if it's a question like A, where I have a number that I'm plugging in, it's always going to be easier to plug that number in first. So I have f of g of negative 1 for number 55. That means that I'm going to start by plugging negative 1 in to g everywhere I see an x. So this would be g of negative 1 equals 1 over the square root of negative 1 plus 2. That's where I plugged the negative 1 in at, because there was an x there. Negative 1 plus 2 is 1. So this is 1 over the square root of 1, which is 1 over 1, which is just 1. But that's just for my g function. Now I take this 1 and plug it back into f, and it's 1 over 1 still, so that gives me 1. So f of g of negative 1 is 1. Part B, g of f of 2 means I start by plugging a 2 in for the x here. So that starts as 1/2. Whatever I get there, I plug into the g function. So that's 1 over square root of 1/2 plus 2. 1 over square root of 2.5. Square root of 2.5. I don't know that off the top of my head, although I probably should. I shouldn't. That's 1.581138883. And so we divide 1 by that answer. Gives us 0.6325. I could also multiply, which is going to be even better. Multiply both the top and bottom by the square root of 2.5, which is going to cancel that bottom out. It's just going to be 2.5. On the top, this is now square root of 2.5 over 2.5. And that's it. And that process is just rationalizing the denominator. Part C is f of x, which means I'm just going to take this f of x and plug it back in everywhere I see an x. So if it's 1 over x, I'm plugging 1 over x in everywhere I see an x in here. So this is 1 over x. Because of that, I can treat this one up top like a 1 over 1, and then multiplied by the reciprocal of the denominator, which gives me x. If I'm looking at g of g, that's far worse. It's going to be 1 over the square root. And now everywhere I see an x plus 2, I do 1 over the square root of x plus 2. x plus 2. I would accept this as an answer just because this one is horrendous. So that one wouldn't be too bad. Last type is write a formula for f of g and g of f. So whenever I do this, if I'm doing fog or f of g, means I take this whole thing and put it in everywhere I see an x. So it gives me 2 minus square root of x plus 2 squared. Now if I do square root of x plus 2 squared, the square root and the squared cancel out, and I'm just left with 2 times x plus 2, which is 2x plus 4. Doing Goff now. It's going to be the square root of 2 minus x squared plus 2. This is going to give me negative x squared plus 4. And we're taking the square root of that. And that's all we can do with it. Last ones, and I'm only going to bring these up because I'm not going to actually want you to graph them. What I want you to find is the amplitude, the phase shift, the vertical shift, and there's another one. Amplitude, phase shift, vertical shift, and the period. So if I look at one like number 73, 2 out front changes my amplitude. So my amplitude now becomes 2. My phase shift is to the right by pi over 3. Vertical shift, there's nothing added on to the end or the beginning, so that would be 0. And my period is pi over whatever's in front of the x, which is just 1 in this case, so it's just pi. If I'm looking at this one, very similar. I have a pi over 4 phase shift, so it's going to be left by pi over 4. This is my vertical shift, it's up 1. My amplitude, there's nothing being multiplied by it, so it doesn't change. My period remains pi, and that's it. For 71, because this is sine of pi x, then in order to find my new period, I do 2 pi, because that's how long it takes sine to circle through it all, divided by pi. It gives me 2. So that's how I would find my period. If there are any questions on any of those, feel free to either email me tonight or send me a message on Google Classroom. Alright guys, don't forget to hit that like and subscribe button. Like and subscribe.